For decades, astronomers have warned us. In 5 billion years, our Milky Way galaxy will collide with Andromeda, our nearest galactic neighbor. It was considered inevitable. But a groundbreaking 2025 study just revealed something shocking. The collision might not happen at all, or if it does, it could be delayed by another 5 billion years. The chances? 50-50. Professor Alice Deason from Durham University led the research rewriting galactic destiny. Using unprecedented data from the Gaia and Hubble space telescopes, scientists discovered that uncertainties in our measurements mean what seemed certain is actually up for debate. Today, we're exploring why our galaxy's future isn't written in stone. Galaxy collisions are driven by one fundamental force: gravity. The more massive something is, the stronger its gravitational pull. This is why objects in space naturally fall together, merging to form bigger structures. Our Milky Way exists in what astronomers call the local group, a collection of galaxies all gravitationally attracted to each other. While the universe expands, localized regions like ours have so much mass that galaxies group rather than drift apart. Galaxy collisions happen throughout the universe. However, as Professor Deason emphasizes, collision is misleading. What really happens is far more interesting. Professor Deason prefers the word merger because stars don't actually crash into each other like snooker balls. Galaxies are mostly space. Stars gravitationally interact, redistributing around each other, but direct collisions between stars are infrequent. The most energetic events occur at galactic centers where supermassive black holes merge to form even larger black holes. This creates an active galactic nucleus, or AGN, releasing enormous amounts of light and energy. Paradoxically, galaxy mergers trigger intense star formation. Compressed gas clouds ignite, creating millions of new stars in violent but creative cosmic events. For years, astronomers believed the Andromeda-Milky Way collision was inevitable in 5 billion years. However, Professor Deason's team found that the probability drops to just 50% when accounting for measurement uncertainties, and if it happens, it might not occur for 10 billion years. Predicting galactic collisions requires knowing three things: how far apart galaxies are, how massive they are, and how fast they're moving. These sound simple, but Andromeda is over 2.5 million light-years away. Even tiny measurement uncertainties become enormous at that scale. That small wiggle room in measurements can mean the difference between a direct hit and a near miss that sends galaxies past each other. Two space telescopes made this breakthrough possible. Gaia, launched by the European Space Agency in 2013, maps the motion of stars within our galaxy to exquisite detail. It's completely revolutionized our understanding of the Milky Way's structure and dynamics. Hubble's high-resolution camera provides the other piece. Astronomers measure incredibly tiny movements across the sky by comparing images taken years apart. The longer the time baseline, the more accurate the measurements. James Webb will soon contribute even more precise data. If the merger does happen in 5 billion years, our solar system would likely just be nudged into a different orbit. Stars wouldn't collide. But there's a catch. By then, our sun will have evolved into a red giant, possibly engulfing Earth. As Professor Deason notes, we'll have bigger problems to worry about. If the merger happens, the beautiful spiral arms of both galaxies will transform into a massive elliptical galaxy. But whether it's 5 billion years, 10 billion, or never, one thing is certain: the universe still has the power to surprise us.